Today I'm going to teach you how to use the simulation tool to model stress on an object from weight, for instance. So here you can see I've designed this bracket that could be used to hold up something here, like a main support beam here and holding up something here. What I'm going to do is go into the simulation tool, into the simulation workspace here, and you can see all the different options of studies. You have to use the static stress study here to observe the stress forces. What you have to do here is use the tools up here to basically show Fusion what to do. First, you have to highlight the structural constraints. So these are the objects where your object will be mounted. So for instance, if I have a main mounting position here, I'd select the structural constraint to be here. Next, what I need to do is select loads. So the load would be here and acting downwards. Unlike the adaptive clearing, this one, the magnitude does matter. So let's say we have a 100 kilogram object leaning off the side of this. So that's 10,000 newtons. Well, somewhere around that, I can't remember. Next, what we want to do is adjust the mesh size and make it as small as possible. This will give the simulation more points to work with and will allow for more accurate simulation. Some other things you can do is select the material of the of your object. So for instance, here we have a steel part. You can see that as it's selected. You can go down and add more materials later on if you need them. Finally, you can run the mesh compute here by clicking that button. And so here the mesh has come out, and click solve here. Depending on the power of your computer, you can do it on cloud if you have a less powerful computer, or locally if you have a decent computer. I have a decent computer here, so I'm gonna click solve locally. This will take a few seconds to a few minutes, depending on the spec of your PC. As you can see, mine's getting done pretty quickly. Right, now that the simulation is complete, we can see that you can see the safety factor here, despite being nice, is pretty low. You'd usually for a product you'd usually want it to be in this green region here, but as you can see, we are deep into the red. You can see it highlights the exact problem areas. So you can see that these joints here are the structural weak points of the entire build here. So you can see here. So what you can do to fix this is bulk them up, for instance. So let's for instance make this a little bit bigger. Add some mass to this here and here. Now, as we can see, we bulked up the areas where the simulation said we'd have structural weak points. So now if you run the simulation again, using all the same parameters, we can click solve. And once again, we can check the simulation to see if the situation has improved. Right, you can see that the simulation is done again, and you can see that the simulation reports a much better safety value here. However, it is still in the generally unsafe scenario. And you can see it highlights the main points of concern. And You just repeat this process again and again until you have a completely safe product. Thank you for watching.